In the last decade, once the gold standard of aviation, has faced a series of devastating crashes, from the infamous 737 MAX disasters to the shocking 2025 Air India Dreamliner tragedy. Engines failing mid-air, faulty software, missing bolts, and now serious questions about culture, oversight in profit-driven engineering. How did the most trusted name in flight become the subject of global investigations, congressional hearings, and passenger fear? This isn't just about airplanes. It's about what happens when safety systems fail and lives are caught in the fallout. Today, we're pulling back the curtain on why Boeing planes are crashing. June 12, 2025. Air India Boeing 787 crash. On the morning of June 12, 2025, Flight AAI-171 prepared for a routine departure from Ahmedabad to London Heathrow. It was a Boeing 787 Dreamliner, a modern marvel of aviation. The crew ran their checks, passengers buckled in, and the aircraft rolled onto the runway. But within seconds of takeoff, something went catastrophically wrong. Both engines, Rolls-Royce Trent 1000s, lost thrust simultaneously. There was no explosion, no fire, just silence and descent. Pilots tried to recover, but the aircraft lost altitude too quickly. At 2,100 feet, the plane banked hard, stalled, and slammed into open fields outside the city. The crash killed 260 people. Miraculously, one passenger survived. What happened in the cockpit became the subject of global scrutiny. The initial black box analysis revealed something deeply disturbing. Both fuel control switches, critical components that control the flow of fuel to the engines, had been manually switched to cut off. In simple terms, the engines were starved of fuel mid-takeoff. The question then wasn't just how it happened, but why. It's not possible for both switches to be flipped accidentally, said an aviation analyst quoted in the Times. The design of the switches requires physical effort and intention. Yet, there it was. The switches were off. The cockpit voice recorder captured confusion between the pilots, both seasoned professionals, arguing about who had moved the switches. One denied it, the other wasn't sure. And in those final minutes, the transcript spiraled into chaos. That chaos has fueled speculation, ranging from deliberate sabotage to startling mechanical vulnerability. In the days following the crash, the Indian Directorate General of Civil Aviation, DGCA, stated that no maintenance faults were found. There were no leaks, no pressure drops, no evidence of a fuel system failure. What was found, however, were the switches, flipped cleanly, conclusively, to off. This wasn't just a crash, it was a puzzle, a technical anomaly wrapped in human uncertainty with devastating consequences. And it sent ripples far beyond India. As The Guardian reported, aviation regulators across Asia and Europe scrambled to issue temporary fuel switch inspections on Boeing 787s. The UK Civil Aviation Authority, CAA, quietly released an alert just weeks before the crash, warning of potential switch disengagement during flight. And though the advisory had been non-mandatory, the timing raised eyebrows. This tragedy reopened a dangerous question the world thought it had shelved. Are Boeing aircraft, once a symbol of industrial excellence, now vulnerable by design? As the investigation deepens, and as grieving families search for answers, one unsettling fact remains. This disaster began not with smoke or fire, but with the quiet, almost invisible cutoff of fuel, and with it, the illusion of infallibility in modern aviation. Design or design flaw? As wreckage teams dissected the cockpit remains of Flight AI-171, one question took shape. How could two fuel switches be flipped mid-takeoff? These aren't casual buttons. They're mechanically gated switches designed to resist accidental contact. So for both to be in the cutoff position at the exact moment when full engine thrust was critical raised alarm bells across the aviation world. Boeing's official manual describes the switch as guarded against unintended operation, and industry engineers confirm it requires deliberate force. But documents uncovered by the Washington Post revealed that the FAA had flagged a potential vulnerability back in 2018. Under specific circumstances, the locking mechanism could disengage during high vibration phases, such as takeoff. Yet this warning wasn't mandatory. Airlines weren't forced to act, and Boeing didn't redesign the part. Even more troubling, just weeks before the Air India crash, the UK Civil Aviation Authority, CAA, issued a quiet bulletin to operators of the 787 Dreamliner, recommending checks on the switch mechanisms after anecdotal reports of mid-flight disengagement. The timing, in hindsight, is chilling. The DGCA in India responded to the crash by issuing an urgent inspection order to every airline operating Dreamliners in the region. All of this raises a deeper engineering question. Was Boeing's switch design flawed from the start? If something as essential as fuel control can be compromised without warning, it calls into question every layer of redundancy Boeing is supposed to build in. It's supposed to be fail-proof, said a former Boeing quality engineer to Barron's. But that doesn't mean it's failure-proof. Pilot error or intentional acts? The next layer of the story shifts to a more uncomfortable space, the human element. When the cockpit voice recorder from Flight AI 171 was finally decrypted, it revealed an auditory mosaic of confusion and conflict. Both pilots, trained, certified, and previously without major incident, argued over who moved the fuel switches. Neither admitted to the action. One pilot shouted, "What are you doing?" while the other reportedly replied, "I didn't touch it." This exchange, preserved on tape, has ignited fierce debate across the global aviation community. Some analysts suggest an accidental elbow movement, perhaps a stray motion under pressure. But multiple sources, including The Sun and The Times, quoted industry experts calling that vanishingly unlikely. The switches require a lift-then-toggle movement, a deliberate act, which leads to a darker question. Was it intentional? Investigators have since reviewed the mental health and recent behavior of the crew. While personal struggles have been mentioned in passing, no conclusive evidence of malice or impairment has emerged. Still, authorities aren't ruling anything out. This isn't the first time pilot behavior has come under scrutiny. From the German wings crash in 2015 to more recent cockpit incidents in Asia and the US, the aviation world has been forced to confront the vulnerability of human beings at the center of complex machines. But here's the takeaway. Even the most advanced aircraft in the world can be undone by a single human decision. And the more Boeing relies on automation and system design, the more it must also anticipate and defend against human unpredictability. Could known faults play a role? Behind the switches, another theory lurks, less visible but just as powerful. Software failure. One U.S. attorney, representing families of the deceased, told the Washington Post that a known Boeing 787 software bug may have created a cascading effect, cutting engine thrust during takeoff. While Boeing has denied any systemic design flaw, the claim has prompted a second wave of inquiry, this time into code, not cables. Investigators from India and the US are now simulating the crash with the exact conditions recorded from the flight data recorder, FDR. Their goal? Recreate a scenario in which both engines fail simultaneously, even without direct human input. Early results have been inconclusive, but internal memos obtained by Slash.tech point to intermittent conflicts between the auto throttle system and fuel metering logic, a rare but potentially lethal glitch. Software doesn't crash like a bird hits a window, said an aviation software engineer interviewed by the Economic Times. It unravels silently, line by line. Boeing, in partnership with General Electric, the engine supplier, has stated publicly that no design defect has been identified. But the very fact that regulators are simulating such a condition suggests a credibility gap, and possibly a history of unresolved bug reports. The 787, like all modern jets, is a flying computer. But unlike your laptop, you can't hit restart at 30,000 feet. And as systems become more automated, software isn't a supporting actor. It's a lead character. Lessons from 737 MAX disasters. For many, the Air India crash stirred not just grief, but déjà vu. The shadow of the 737 MAX disasters loomed large. In October 2018, Lion Air Flight 610 plunged into the Java Sea. Just 5 months later, Ethiopian Airlines Flight 302 met the same fate. Both involved a single system, MCAS, or the Maneuvering Characteristics Augmentation System, designed to automatically push the nose of the aircraft down to avoid a stall. The flaw? It relied on just one sensor. If that sensor failed, which it did, the system would push the aircraft nose down repeatedly, even when it wasn't needed. And worse, Boeing never told pilots about it. The system wasn't in training manuals. Pilots weren't briefed. Lives were lost because they didn't know what they were fighting. In total, 46 people died. Investigations revealed that Boeing had implemented MKS to avoid triggering expensive simulator retraining for airlines. In effect, corporate cost-cutting led to catastrophic design choices. Enrico Dolphin, a business analyst, summarized the decision-making as follows. They optimized for certification, not safety. What's more disturbing is that the MCAS failures weren't immediately treated as red flags across the rest of Boeing's fleet. The Dreamliner doesn't use MKS, but the same culture of quiet patches and corner cutting echoed into future models. Which brings us back to Flight AI 171. Whether switches or software, design flaw or crew mistake, the broader theme remains. Boeing systems are only as safe as the decisions behind them. And as the MAX saga taught us, one overlooked failure can take hundreds of lives and billions in trust down with it. Fleet groundings and regulatory overhaul. When the 737 MAX went down twice, the global aviation system didn't just react, it convulsed. In March 2019, after the second crash in Ethiopia, country after country grounded the MAX. It began with China, then Europe, then eventually the FAA, making it one of the most sweeping groundings in aviation history. For 21 months, the 737 MAX fleet was parked. It was the first time in modern aviation that a single aircraft model was banned from global skies. Not because of weather or war or a temporary glitch, but because of a flaw built into its core. In the aftermath, regulators worldwide tightened the screws. The FAA, EASA, and Transport Canada began to overhaul certification protocols. The days of self-certification, where Boeing engineers could sign off on their own systems, were now under fire. As lawsuits stacked up, so did fines. In 2021, Boeing reached a $2.5 billion settlement with the U.S. Department of Justice. That figure included criminal penalties, compensation to airlines, and a fund for victims' families. But critics said it was a slap on the wrist. After all, Boeing's annual revenue hovers around $75 billion. Even now, the DOJ is reconsidering new charges, citing Boeing's repeated failure to fully meet terms of the agreement. The public, and many in Congress, want answers and accountability. As one analyst told Hill Law Firm, this wasn't just a design issue, it was a regulatory failure, a governance failure, a cultural failure. In short, Boeing's name, once synonymous with trust in aviation, now sits under a global microscope. And every new incident, like Flight AI 171, isn't viewed in isolation. It's weighed against the memory of two doomed MAX flights and the systemic gaps that allowed them to happen. Manufacturing mistakes. The problem with Boeing hasn't just been software or design. Increasingly, it's the build quality itself. After years of pressure to speed up delivery timelines, what once felt like precision craftsmanship has begun to resemble assembly line haste. In January 2024, an Alaska Airlines 737 MAX 9 had to make an emergency landing after part of the fuselage, specifically a door plug, blew out midair. The cabin depressurized. Passengers panicked. And when investigators examined the plane, what they found was astonishing. The door plug was missing 4 key bolts. They were never installed. Soon after, FAA audits discovered even more. Misdrilled bulkheads, loose rudder bolts, and excessive gap tolerances, all pointing to a breakdown in quality assurance at Boeing's Renton and Charleston facilities. These aren't minor oversights. These are fundamental, life-critical failures. A whistleblower speaking to the New York Times said plainly, "We're not fixing airplanes anymore. We're rushing them out the door." What's driving this? Boeing's competition with Airbus, shareholder pressure, and years of management culture focused on cost and speed. Internal metrics reportedly prioritize delivery deadlines over inspection backlogs, an inversion of priorities that left gaps, both literal and metaphorical, in every airframe. And now regulators are stepping in. The FAA has opened a broad investigation into Boeing's 737 MAX 9 production lines, and Congress is calling for external oversight of Boeing's supply chain. But the damage is done. In the minds of the public and pilots alike, there's a growing sense that something essential has eroded inside Boeing's walls. The commitment to uncompromised build quality. Engineering versus profit. If you want to trace the roots of Boeing's recent failures, you don't start in the factory or the cockpit. You start in the boardroom. Back in the mid-1990s, Boeing merged with McDonnell Douglas. On paper, it was a unification of aerospace titans. In reality, it was the moment Boeing began to pivot from an engineering-first company to a Wall Street-managed business operation. Over time, cost reduction became the guiding principle, and engineering oversight was quietly marginalized. Leadership failure, not technical failure, is Boeing's core issue, wrote a 2024 white paper by Harvard Business School and IChemE. It laid out how internal memos deprioritized safety reviews, delayed simulator testing, and approved software updates without full transparency. In the MCAS saga, this culture manifested starkly. Whistleblowers reported being pressured not to delay launches, even when flaws were still being debugged. Engineers who raised concerns about sensor dependencies or simulator training were ignored, or reassigned. The case of John Barnett, a Boeing quality manager who raised alarm over improperly secured oxygen tanks and was later found dead under controversial circumstances, cast an even darker shadow. His story fueled growing fears that internal dissent wasn't just discouraged, it was silenced. And even as Boeing faced record-breaking settlements and criminal probes, top executives were rewarded with multi-million-dollar bonuses. As one former engineer stated bluntly, the culture changed from "will it fly safely" to "will it ship on time." Today, Boeing's crisis isn't just technical, it's existential. Because if a company builds planes faster than it can ensure they're safe, the consequences don't show up on balance sheets. They show up in wreckage fields, in devastated families, and in the growing reluctance of passengers to trust a once revered brand. Pilots left vulnerable by Boeing. In aviation, technology is only as safe as the hands guiding it. But what if those hands are flying blind? The crashes of Lion Air and Ethiopian Airlines exposed a chilling reality. Pilots were not fully trained on the systems that doomed their planes. The MCAS system, the software that triggered nose-down commands, was not even mentioned in the original training manuals. Many pilots didn't know it existed. Boeing's reasoning? If MCAS was marketed as a minor addition, the company could avoid costly simulator training requirements for airlines. This decision helped Boeing sell the 737 MAX faster, especially to budget carriers. But it came at a deadly price. Pilots aboard both flights fought against an automated system they didn't understand. In the Lion Air cockpit, a young crew struggled to diagnose why the nose kept dipping. In Ethiopia, seasoned aviators desperately scanned checklists as the jet plunged. Neither crew had received dedicated MCAS simulator training. Both planes crashed within minutes of takeoff. After the second disaster, Boeing reversed course. MCAS training was made mandatory and regulators stepped in. But the damage had already been done. Hundreds dead, billions in lawsuits, and the public trust frayed. The Air India crash of 2025 now raises new questions. If the fuel switches were flipped by human hands, were those hands fully trained on the quirks of the Dreamliner's fuel control systems? Was there sufficient hands-on simulator time, or only classroom briefings? Were there cultural gaps, language barriers, or airline-specific procedures that Boeing's manuals didn't account for? Experts stress that training cannot be retrofitted after a disaster. It must be part of the system from the beginning. Yet Boeing, time and again, has treated pilot readiness as an optional layer rather than a foundational pillar. Pilots aren't the backup system, one safety inspector told ProSolver Tech. They're part of the software loop, human, but essential. Without complete training, even the best hardware becomes a loaded question. And passengers are the ones gambling on the answer. Regulator weaknesses. For decades, the FAA was considered the gold standard of global aviation safety. When the FAA spoke, the world listened. But the crashes of the 737 MAX and the 787 Dreamliner shook that authority, and not just because of what the planes did, but because of what the FAA failed to do. During the certification of the 737 MAX, the FAA had allowed Boeing to use a self-certification model where in-house engineers, paid by Boeing, were authorized to approve critical flight systems, including MCAS. This was done under a system called Organization Designation Authorization, ODA, meant to speed up approvals. But in reality, it meant the fox was guarding the henhouse. When both MAX crashes occurred, international regulators were shocked to learn how little external scrutiny the FAA had applied. The agency delayed grounding the aircraft, only doing so after mounting global pressure and hard data. Now, similar questions are emerging with the Air India 787 crash. Why weren't fuel switch vulnerabilities corrected after FAA advisories in 2018? Why was the UK Civil Aviation Authority issuing warnings ahead of the FAA? And how did a known design issue already flagged go unaddressed for years? In response, some regulators, like ECO in Europe and DGCA in India, have begun asserting more independence. They're no longer rubber-stamping FAA approvals. Boeing aircraft are now subject to multi-jurisdictional audits, something that would have been unthinkable a decade ago. As one aviation law expert told The Guardian, the FAA's credibility hasn't just been questioned, it's been restructured from the outside. Today, safety doesn't just depend on the aircraft or its manufacturer, it depends on whether the watchdogs are wide awake. From preliminary to final, after the crash of Flight AI-171, the preliminary findings came fast. The engines failed, the fuel switches were off. There was no evidence of sabotage or mechanical failure. But in aviation, preliminary doesn't mean final, and the real answers often take months, even years to surface. Currently, a joint team comprising experts from India's DGCA, the US NTSB, and Boeing itself is reconstructing the flight second by second using data from the Flight Data Recorder (FDR) and Cockpit Voice Recorder (CVR). They're simulating different conditions: fuel starvation, software interference, and cockpit miscommunication. Every detail is tested again and again. What makes this case especially complex is the lack of precedent. Twin-engine shutdowns during takeoff are extraordinarily rare. For both engines to fail simultaneously without fire or explosion suggests either a bizarre mechanical coincidence or a very precise human action. Adding to the mystery, insiders familiar with the investigation have hinted at a possible software contribution. Some reports suggest the auto-throttle system may have misread a fuel feed cutoff signal, or that a conflict between multiple logic layers could have caused a cascading failure. As of now, nothing has been ruled out. The final report isn't about blame, it's about truth, said one investigator to Slash.tech. And truth in aviation takes time. The full report is expected in mid to late 2026, possibly longer. Until then, regulators are treating the incident as a live safety concern, not a closed case. What comes out of this investigation will shape airline training, design audits, and even public confidence for years to come. Because in aviation, every crash is a data point, and every report is a chance to stop the next one. Boeing's road to redemption. Boeing now stands at a crossroads. The company can either patch the surface and move on, or rebuild the foundation and its reputation from the inside out. Step one is hardware accountability. The fuel control switch mechanism on the 787 must be redesigned for foolproof locking. No assumptions, no ambiguity. Similar to MCAS updates, the system needs redundant safety interlocks that prevent unintentional shutdowns during takeoff or flight. Step two is software transparency. Boeing must ensure that automated systems can be fully overridden by pilots without delay or confusion. This includes documenting every behavior, every edge case, and making that information accessible in training. Third, and perhaps most urgently, is manufacturing reform. After the Alaska Airlines door plug scandal, Boeing must implement external inspections at critical production phases, not just end-stage audits. Every missing bolt, every misaligned panel is a signal, and lives depend on those signals not being missed. Fourth, Boeing must shift from defensive PR to proactive accountability. This means cooperating fully with regulators, acknowledging past missteps and publicly committing to safety over speed. Not in vague statements, but in data-backed action. We're rebuilding trust, one aircraft at a time, a Boeing spokesperson told Reuters. That's not just a slogan, it must become the company's new engineering religion. True redemption isn't found in court settlements or press releases. It's measured in years of safe flying, transparent systems, and engineers who feel empowered to speak up, not rush to shut up. Why it still matters to you and me. You may never walk into a cockpit, you may never touch a flight manual, but this story of switches and software, lawsuits and lift is still about you. Every time you board a plane, you place extraordinary trust in something invisible. A network of engineers, pilots, regulators, and systems that promise to get you home safely. When that trust breaks, even once, it sends ripples through every passenger cabin in the world. Boeing isn't just a company, it's the backbone of global aviation, carrying millions of passengers every week on every continent. Its planes carry your vacations, your business meetings, your loved ones, and yes, your life. So when design shortcuts are taken, when warnings go ignored, when training is watered down or production is rushed, the consequences don't stay inside corporate boardrooms. They echo in real families, real loss, and real fear. We expect safety by default, said one former pilot, but safety has to be earned again and again. This story isn't about fear, it's about vigilance. Because the moment the public stops asking questions, the cracks start to grow. Not just in rivets and software, but in accountability itself. And if history has taught us anything, it's this. Planes don't just fall from the sky. They're failed by the systems meant to protect them. Boeing's future now hangs on accountability. Real, structural, and lasting. Because when one jet goes down, it grounds confidence in the entire system. Safer skies don't happen by default. They're built, bolt by bolt, decision by decision. And every crash is a warning we can't afford to ignore again.